Eratosthenes, a Greek mathematician and astronomer who lived in the 3rd century BCE, is famous for his calculation of the Earth's circumference. He accomplished this by measuring the angle of the sun's rays at 2 different locations and then using some basic geometry. Here's a brief overview of how he measured the Earth's radius. Eratosthenes observed that on a specific day, the summer solstice, the sun was directly overhead in the city of Syene, modern-day Aswan, Egypt. This meant that at noon, the sun's rays fell directly down a well in Syene, causing no shadow. Simultaneously, in Alexandria, located north of Syene, Eratosthenes noted that on the same day, there was a measurable shadow at noon when the sun was not directly overhead. Eratosthenes used a vertical rod in Alexandria and measured the angle of the shadow it cast during the noon hour when the sun was at its zenith in Syene. He found that the angle of the shadow was about 7.2 degrees. Knowing the distance between Syene and Alexandria, approximately 800 kilometers or 500 miles, Eratosthenes used this angle to estimate the Earth's circumference. He assumed that the angle formed by the shadow was a fraction of the total circumference of the Earth. The fraction was the ratio of the distance between Syene and Alexandria to the Earth's circumference. He calculated the Earth's circumference using the formula circumference equals sine, distance between Syene and Alexandria, angle of the shadow. Although Eratosthenes' actual measurements may not have been perfectly accurate, his methodology was sound and his estimation of the Earth's circumference was remarkably close to the modern value. Eratosthenes' work is a brilliant example of early scientific reasoning and the application of geometry to solve real-world problems.